Today we are going to go through with planes, and we are going to show how two planes are parallel, and then we're going to find the distance between them. So we are given with plane 1 and plane 2, their equation. So all we need to do to show that they are parallel planes, we just need the normal for plane 1 and plane 2. So I'm going to write it down. For the normal for plane 1, that will be 2 minus 2, 1. And the normal for plane 2, that will be negative 4, 4, and negative 2. And you can see that in order to prove that they are parallel, all we need is just to show that they have a common vector or they have a common matrices. So you can see that from plane 2, I can factorize out, I can take out my negative 2. So I can take it out, my negative 2, that will give me 2, negative 2, and 1. And you can see that plane 1 and plane 2, they share a common vector. That means that they are parallel. So all I need to write down is, I just need to write down a simple statement that since np1 is equal to negative 2 of np2, and therefore the planes are parallel. Okay, so the planes are parallel. So that is all you need to show, and you can prove that the planes are parallel. So we're going to jump straight into how to find the distance between the plane. So now we know that the two planes are parallel, we have to find the distance between them, between the two parallel planes. And as you can see that I have factorized out my negative 2 from the normal of plane 2, I'm going to change a little bit to the equation of plane 2. I'm going to bring the negative 2 to the other side of the equation. That will get me 7 over negative 2. That will get me 7 over negative 2. But in order for that equations to stay true, we need to change this to 2 minus 2 and 1. And as you can see, plane 1 and plane 2 now have a common normal. Okay, so how are we going to find the distance between them? So let's try out with plane 1 first. What we're going to do with plane 1 is that I'm going to write this down. You can see the yellow formula I have here. So that will be 2 minus 2, 1 over square root of my 2 square plus negative 2 square plus 1 square. Okay, so once I press this in the calculator, I will get something like this: 1 over 3, 2 minus 2, and 1. And to make this true, it means that we need to multiply both sides by 1 over 3, and that will get me 5 over 3 for my plane 1. Okay, now we're going to do the same for my plane 2. So for plane 2, we will have something like this. Okay, so that is the formula, that is the equation that we have for plane 2. So it's going to be the same thing. We have 2 square plus minus 2, 2 plus 1 square. And if you're going to press this in the calculator, you're going to get the same thing. You're going to get this 1 over 3, 2 minus 2, 1. Okay, that means that you need to multiply the other side of the equation by 1 over 3. We have 7 over negative 2 there. So if we multiply, we will get negative 7 over 6. Okay, so we have found these two. We have found this. We have found this. And we have found this. So what does this mean? All you need to do is to find the difference between them. So it's going to be something like this: 5 over 3 minus 7 over 6, and this will get me 5 over 6 units. And this is the distance between the two parallel planes. We are going to show that the line is parallel to the plane, and in order to do that, we need the directional vector from the equation of the line. So it's going to be 1 minus 1 and 4, and we also need the normal from the plane. So we're going to do this. We're going to take the normal from the plane, okay, the normal from the plane, and scalar multiply with my directional vector from the line. And they're going to give me something. That's going to give me something. Okay, so I have my 1, 5, 1 scalar product with 1 minus 1 and 4, and this will get me a 0. This 0 shows that the line is parallel to the plane. Now, since we know that the line is parallel to the plane, we are going to find the shortest distance between them. So first, we're going to let my parallel plane in which my line lies be a plane. So you got to imagine that the line now is lying on a plane, and so I have a plane, right? The line is on a plane, so we're going to get that with this. So this is going to be another plane. Okay, so we're going to find where the line lies on this new plane. So we have the normal to be 1, 5, 1, and we need a point on the line which is negative 2, 2 and negative 3, and then we're going to scalar product with my normal. So we're going to solve whatever on my right hand side. Okay, and if you're going to solve this, you get 5. Okay, you get this 5. Okay, so this is the plane. I'm going to use the plane, I'm going to use this, and I'm going to use this to show that, no, to find the shortest distance between them. So it's the same thing as what we do to find the shortest distance between two planes, two parallel planes. So what we're going to do first is I'm going to use my plane. Okay, I'm going to use this plane. So I'm going to give this P1. So to do that, okay, we're going to do the same thing. So I have my formula here. So I'm going to write down this, and I have 1, 5, 1. I'm going to square root 1 square plus 5 square plus 1 square, and this will give me something like this. Okay, it will be something like this. 1 over square root 27. Okay, so we have 1 over square root 27. We're going to do that. We're going to multiply it over to the other side, and that will get me negative 3 over square root 27. So we're going to keep this in mind. We're going to keep this, and we're going to use the same thing to do for the next plane. So for the next plane, we also have we're gonna do with this. Okay, we're gonna do this. So we have the same thing. So since you know we are going to do the same thing, so we have 1 over square root 27 as well. So that will be square root 27, and we're going to do it to the other side. So that will be 5 over square root 27. So to find the distance between them, all we need to do is to minus, or in a way is to add them together. So we will have something like this: 5 over square root 27 minus 3 over square root 27, and this will get me 8 over square root 3, no, 8 square root 3 over 9 units. And this is the shortest distance between the line and the plane.